Good morning. Can everyone hear me?
Yep. Yeah, I can hear you.
Okay, awesome. Sorry I'm late. I was up late last night dealing with trying to get a presenter for a conference that has a bunch of investors that we need to talk to there. Uh, Kent, you want to go first?
Yep, sounds good.
Awesome.
So last week merged the new rev address PR and helped with the deploy cost accounting payments. Also, I had to write up a summary of what I've been sort of struggling to express about the unforgeable names.
Okay.
Untold.
Yeah, I want to hear about that.
Yeah, so as especially as like a block explorer, we would need to be able to easily identify and read the values of variables in various smart contract instances. And in Ethereum, smart contract addresses are deterministically generated based on the address and nonce of the user that created the smart contract. And if the creator is another smart contract, then it is the address of that smart contract along with a nonce. And in our chain, we cannot deterministically generate address equivalents, which we would probably call names, based on the creator and the nonce, because Rolang doesn't execute sequentially. So depending on the order of execution, the two contract instances that are newly created cannot be identified without looking into their contents. And in theory, this shouldn't be at least a high priority, because the need to be able to concurrently create two new contracts by the same user or contract isn't what we need to scale. More concretely, we, at least in terms of our current RevVault implementation, we won't be able to make two transfers out to two new RevVaults from the same RevVault in parallel. But as long as we're able to make two independent transfers in parallel, we should be able to scale. And so yeah, that's sort of the identification of the issue. And I'm trying to, so I guess what I have as a suggestion, it's basically to execute continuations from a specific contract name in sequence, which I'm not too happy about, but like maybe it can be built on with this new understanding of the problem.
So that's a very interesting issue. So as I understand it, you need the deterministic address creation to be able to map the names, the unforgeable names to variable locations.
Yeah, that would be, so that would be at least the simple way of matching unforgeable names to variables, or like basically be able to read values that are stored at various unforgeable names. Because otherwise you have to rely upon the contents of what's at a name to identify it, which kind of like it's doable.
That's unreliable.
Yes. But yeah, it's
Unless you put the name itself at the name.
wow. I
mean, you could put the variable name at the name.
So let's say, I don't think that, so if you, let's say you do something like rev vault, I don't know how to say this, but rev vault create vault bang, right? Like that is imagine that's like a creation of a rev vault. And you do that in parallel with another one of those. How do you differentiate between those two instance creations? Without looking at their contents, right? Like the only difference between those is that, let's say the first rev vault.
Well, you can give every instance an identifier.
Yes, and so that's sort of what, like, so as I said, like Ethereum, each instance gets an identifier based on, like, the nonce becomes the identifier essentially.
Yeah, but there's nothing sequential unless the nonces are sequential.
Yeah, the nonce is sequential.
Yeah, so that's the issue. I mean, what you really want to do is just make them distinct, not sequential.
Yes, that is true. Right? It just needs to be distinct.
Yeah, so then you don't really care about, so the parallelism is not the issue. It's just giving each instance its own distinct identifier.
So I guess, how do you give an identifier when like, how do you know what, so let's say you assign A to the first one, although you don't know which one executed first, if that makes sense.
Yeah, and then all internal variables are De Bruijn indices that are prefixed by the identifier.
I guess, but I guess, so the issue is, as a user, how do you know which, like sure, you can say, okay, I'll assign a certain indice to this this instance, but like when I say this instance, it's not clear what that is. I'm not sure if I'm making sense here, but
no, I understand. I think I understand what you're saying. I mean, I think the issue is that unless unless there's some state or something that distinguishes them, they're indistinguishable, right? Unless
Yeah.
you have done some kind of handshake with the contract that identifies the contract, they really are indistinguishable.
Mm,
So right? Because
yes.
otherwise you don't know which one it is, right? And it's like, but that's going to be true whether you're sequential or parallel or whatever it is, right? You got a bunch of instances.
So
So, so go ahead.
if it's sequential, that's not true because you have a nonce attached to the creator of that instance. And so like as a user, the first contract you create has a nonce 1, the second one you create has a nonce 2, and the third one you create as a nonce 3, etc. And like as a
So it sounds like you're asking for the connecting the deployer ID.
Oh, but it's not just the deployer ID. If a contract creates another contract, then
That's the deployer. That's the deployer ID for that one.
well, I don't want to call it the deployer ID because that signals like the oftentimes human, but not necessarily behind it. But yes, like if we want to call that whole thing the deployer ID, always.
Okay. So doesn't that solve the problem? So you now have a deployer ID for each contract. You have the human agent or the external agent, which is a better way of saying it because it might not have been human. It might have been a program that did that too. So you have the external agent that has a deployer ID for the first one, and then you have the contract, the internal agent, which is the deployer ID for the next one, and they're distinguishable.
So you're saying that we should run them in sequence?
No, I'm not. No, but you just gave me a sequential. You just said that a human being started one, and then the contract that they started starts another. So that was a
Oh
sequence.
no. I'm the sort of the example we're under is a user has created 2 rev vaults in parallel.
Okay.
And they want to be able to distinguish between them in the way I've sort of been trying to formulate. I guess I haven't gotten that perfectly down, but yeah, the idea is.
So that create them in parallel, but they have distinct identities, right? I mean, what makes them interesting as rev vaults is that you have a handle to each one.
So you have a handle to each one within the code, but you do not have a handle to each one if you lose those handles.
Yeah, I agree that if you lose the handles, you don't have a handle.
Well, sorry. Yes, of course, but like so. I mean, I know we're not trying to copy every single API that Ethereum has, but it is very useful to be able to, well, not just it. It feels that since the chain state is public in the sense that you can get a copy from someone, and then so like you can basically look into each key, which is a channel, and get out the value. And this process should be easily doable for any value in your state. And at this point, if you can identify, like if you have a deterministic way to generate all the identifiers that correspond to these, it's yeah, like that is at least.
Well, I guess I'm having a hard time understanding precisely who the agents are in the system. Who's trying to know what?
There's only
So
one user.
There's a user, and they're trying to know what?
They're trying to know the rev. They want to be able to see the two rev vaults they've created. Let's say they want to get the balance of both of them, but without creating a getter method ahead of time.
So the addressing scheme that's most obvious is a deployer ID, which is the user, and the address for the Rev Wallet 1 and the address for the Rev Wallet 2.
So the address for the Rev Wallet 1 and 2.
And we don't care which one. We don't care which one is which, unless they have some other distinguishing feature. So there has to be some other context that would say, that you know something more about which one is which.
So you're saying, let's say there's 30 in the first one and 50 in the second. And so I guess you're saying you just have to look into the contents and say the first one has 30, and you have to look into the contents and say, oh, this key has 30, and that's how you identify it, versus sort of being able to know ahead of time, oh, the one that's going in this key, I know even without looking into the value slot in the key value store, it will have 30.
No, you can know that as well, but how do you know that? In the Ethereum case, what is it that you know that's special about Ethereum? It's not just the sequence, right?
You know the key because that key, or the key in the equivalent of the key in our key value store, can be determined based on the address of the user and the nonce the address of the creator of that key and the nonce. So every time they create a new key, it would have a bumped nonce.
I don't know how to say this, but without looking at the code, you don't know whether or not those keys are related to a particular value. You won't know. Okay, so you have to relate those keys to the code. Same here. You have to relate the keys that I'm giving to the code.
But if the suggestion is, sure, just look into the values and, I guess determine the.
No, that, by the way, that isn't the suggestion.
Okay.
The suggestion is that in situations like this, there must always be some form of interaction that distinguishes entities. So either the interaction is set up so that you get specific handles as a part of the interaction, or there's some other aspect of the interaction that allows you to distinguish the entities. I mean, it's really just, I mean, this is the methodology of essentially the pi calculus, right? The pi calculus is just like lambda, except there's concurrency, right? So with lambda, you don't have the identity of anything other than you've got, a variable that you can interact with it, but you're limited in terms of interaction because it's sequential. But it's not even deterministic in lambda, right? It's deterministic in one sense, but order of execution could change from one run to the other. It's just that that the values will always be the same. So unless you have set up as a part of your interaction with the thing some additional identifying characteristics, either by passing another name or by providing some kind of sequence that which provides some information content at the name, there's no way to distinguish them. So identity equals interaction.
Yeah, that sounds right. Yeah.
So, but that means that you can always devise a part of your protocol to provide some metadata, which is identified.
Yep. That, I mean, that feels like a looking into the value approach.
No, it doesn't have to be looking into the value. It can be a step that's associated with, it can be completely on the outside of that value.
Well, isn't metadata sort of a value, if that makes sense?
It can be a value, but the point is that you could send the variable name to one location and the other variable name to another location in sequence, as an example. So you haven't looked into the value of the vault. You go to another location to go and figure out how to distinguish those vaults. That's what I'm saying. It's always interaction. It's not values. In fact, in the pi calculus and in the row calculus, there are no values, right?
Well,
it's even stronger in the pi calculus. But in the pi calculus, there are no values.
Yeah, I guess I'm looking. I have this mental model of this key value store that the tuple space basically represents in my head right now. And with this, I'm thinking it would be like a key metadata value.
Sure.
Or
yeah, you could do that. You could do that.
And so yeah, like it's not a value in the sense of the contents at a name, but it's another value. That's what I sort of meant. Yeah, I see.
Understood. No, this is great conversation. I really appreciate it because this is where how do I say it? Ideology, outlook, worldview, philosophy. I don't know what you call it. Like there's a philosophy embedded in the calculi, whether you're talking about lambda or pi or blue or ambient. There's a philosophy embedded that has to do with being and doing. That's very distinct from the way most programmers think about things, right? Programmers think that there's such a thing as a hard line between data and program. And that's why when they encounter the pi calculus or even the lambda calculus for that matter, they're like, where is the data? And well, there is no data. It's just patterns of interaction. Right. And it really, it comes up in discussions like this. It's all just patterns of interaction. So you have to, if you need to identify something, you have to set up a pattern of interaction that corresponds to its identity.
Yeah, and so I guess that's like a better phrasing of what I was saying earlier about the, like you basically have to create a getter up front if
yeah, something like a getter. Yeah, it's some pattern of interaction. It doesn't have to be a getter, but
yep.
Yeah, something that
The getter is the
identifies.
simplest way I can think of now.
Yeah, sure. Yeah, exactly. I see where you're coming from, but yes, just and trying to leave as many doors open as possible. A getter is just one architecture.
Yes.
Cool. That's awesome. That's a really interesting discussion. I mean, let me know if I can help further in terms of setting up some kind of efficient or secure design. We can do that as well.
I guess so. What came to my head right now was, what if there was, so like what I'm trying to get is some kind of universal getter onto each unforgeable name, if that makes sense. Like without having to have any like further effort by the developer of Roland code to give them a way to be able to distinguish unforgeable names.
So all the unforgeable names, the creation, if you look at the history of the creation of unforgeable names, and if you really believe that that creation can be in parallel, then the entire history is representable by a tree. Do you agree?
So I guess like the part that like the creation can be.
So if you start with the like there's the dawn of time, right? And then at the dawn of time, you can create in parallel some finite number of unforgeable names.
Oh, so it's the ordering of the leaves or the branches don't matter.
Right.
Okay, yeah.
And then from a particular one of those, there comes a request to create more, right? And so
yes.
So okay, so now you see that there's a tree structure.
Well, is there a name for this kind of like, it's like a set at each level, if that makes sense? That
Yeah, it's literally just it's an in-array tree, right? A tree with in branches, as opposed to binary.
I see. So I guess by default, a tree doesn't have
any
an order to.
Yeah.
I see. Okay.
So now you know that once you have a tree, then you can use the addressing on the tree to provide a scheme for naming all the unforgeable names that have ever been created. And so what you can do is you can fill slots in the tree, right? So as you create the unforgeable names, you build the tree, and then you use the tree as your addressing scheme for your unforgeable names. Those addresses cannot be used to access the values of the unforgeable names. They can be, but they can, it's like the unforgeable names can point to something, but the tree addresses point to the names. So they're one level up from the. Does that make sense?
So how do you, like, I guess I'm not sure, like, based on, let's say, it sounds like this tree needs to be written to in, like, it needs to be able to synchronize rights into the.
No. This is just a naming scheme.
So, like, how do you? Yeah. So you have a set at each, or it's a
Think
set
about
of.
it this way, right? I have an API
Mhm.
called Fresh, and Fresh gets me, and just for fun, Fresh can take an integer.
Okay.
Sorry, a positive number. All right, so Fresh with no arguments gives you one fresh, and Fresh with one argument gives you in fresh, and in is not allowed to be 0.
Okay.
Okay, so then whenever I call fresh with in, I and I have to, sorry, fresh takes a root as well. So it takes 2 arguments, a root, which is either the root of the tree or an unforgeable name.
Oh, so wait a minute. Okay. Please go on.
Okay, so now, when I call fresh, I get in names back, and I off of the root that was supplied, I build in children, and I store at those children, or I associate to those children, however you want to do it, the unforgeable names that were created. And I don't really care what the order is. The order doesn't matter. But once I've stored them, now I know that, at child A, I have, one unforgeable name. At child B, I have another unforgeable name, and so on.
Mm-hmm.
So now I have a crisp, clear addressing scheme with for trees. I know how to do that,
Mm-hmm.
right? And then, so all of the addresses in the tree can now point to corresponding unforgeable names. And if I want to have the unforgeable names also talk about their names and their addresses in the tree, whenever I create them, I have to, store, along with the unforgeable name, any value associated with the unforgeable name, its address in the tree as well. So I have a bidirectional pointer.
Oh, so that, I think that answers how to get that distinguishing property. Yeah, I'm not sure what to call it. Yeah, but yeah. I see.
That's just one scheme. I mean, I can think of 10 off the top of my head.
Do you want to go over the next one?
Well, it's.
I mean, like, okay.
I'll leave it as exercise to the reader, unless it's really necessary. Yeah.
Well, I mean, I want to say that I guess I'm not too big of a fan of this like I feel like this tree, if implemented naively, as you just said, it will. I feel like it's. I just don't like the part about having to insert the value.
Oh, having to keep the metadata about the unforgeable name at the unforgeable name.
Well, but maybe like
There's no other way to do it unless you have some deterministic way to compute the unforgeable name. If you don't have a deterministic way to compute the unforgeable name, you can't do it. There's no way to associate a causal link.
Yeah, and I think that is sort of what I initially tried, and that's how like the nons came up. But yeah, I see.
Yeah, that won't work. Yeah, stuff, right? And this is exactly why in physics, where you have the light cone, right? There are time-like distances and space-like distances, and when you have space-like distances, there are events that you can't order. So you really don't know. You don't know how, you don't have any way to distinguish them unless those events carry information about themselves that distinguish them. This is an information flow problem. You can't do this unless you can either set up a deterministic algorithm or you create the causal link by doing storage. That's all you got. There's nothing else.
I see.
And that's provable.
So I guess now the question is, how do you do the storage as efficiently as possible, right?
That part is easy, right? Because addressing schemes and trees are really easy to compact. So the only thing that's difficult is the extra added thing that when you do your storage, when you do your unforgeable name creation, you have to pack it with the extra information.
Got it.
Yeah. And then you also have to know whenever you're retrieving values that you only retrieve a projection to the total value, right? You don't retrieve the name part unless you're specifically told to do that.
Sounds good. Yeah, I'll continue mulling over this.
No, I appreciate it. This is really fun. I love this kind of conversation. Sort of along similar lines, I got distracted from the work on verifying the transition function. Making sure that you don't have an entire shard colluding on COM events that just could never happen. I figured out that the square root of a process, actually the nth root of a process, gives you a equational characterization of decentralized consensus. So I have been thinking a lot about this. Does this make sense? Do you understand what I mean?
I'm not following.
So yeah, okay. So let me describe it in a little bit more detail. So let's just talk about the square root of a process. What is the square root of a process? The square root of a process is, let's say P is our process. Then square root of P, par square root of P, is bisimilar to P.
Do they have to be the same?
And if
like the square roots?
Do they have to be the same? Yeah, I mean that's what it means to be a square root. It's not 3 times 4. It's 3 times 3 that is the square root of 9. It's 2 copies of 3.
So to give an example, is it like let's say nil is P, then the square root
Root of nil is nil.
Of nil is nil. Yeah. Okay.
Yeah. Okay. Cool. So that's one of the interesting. Now, if you push it through equationally, what you end up with is that it pretty much pushes through everything, except tangles where you have races. So you have just reduce a 4 at x together with this at x. So that's the basic red x, and then you have a race if you have either an extra send or an extra receive in par with that red x that is also interacting at x. That's your most basic race, but you could have some giant tangle of potential interactions, right? So you could have a 4 with n sends, or you could have n 4s with 1 send, or any combination thereof. So if you have some tangle, then that's the point at which you have to make sure that the square roots of that tangle, which end up just being 2 copies of the tangle, they all agree on the winners of the race. That's literally the equational characterization. Does that make sense?
You cut off on a large chunk of the beginning.
Oh, shoot. Darn. Okay. What was the last thing you heard?
Well, so I heard the last part about how the square root of I guess I didn't hear the definition of the tangle.
Oh, okay, yeah. So the a tangle is it's essentially some collection of races, some possible races where all the races are happening at a particular name, right? So the simplest form of a race is you've got either 1 for comprehension and n sends, all on the same name, or you've got n 4 comprehensions and 1 send, all on the same name. But then you could have m 4s and n sends, all at the same name. So that's a tangle, right? Because you don't, because you have like lots of different ways that could go, right? They're all intertwined. There's a knot there, and everyone has to agree on how you resolve the races. And in particular, the square roots all have to agree on how the races are resolved, and that's exactly what Casper's doing. It's the only function that Casper provides for us.
So it gives an ordering to the races in the tangle.
It doesn't give an ordering; it just agrees on the winners.
Oh yes, that's I guess what I meant. Yeah, agrees on the winners. Yep.
Yeah. So now I have given you an axiomatic presentation of what consensus is in this setting. I've told you precisely, and I can give you a definition, right? It's like the square root is going to do that. So, but the square root would be having 2 validators. The nth root is having n validators.
So I'd like to add that Casper does that, and it does the it chooses which terms. So basically, that is what Casper does within a block, and across blocks, it also chooses which terms to par in.
Oh yes, that's correct. Yes, that's fair. So anyway, so I'm busy sort of sketching this out
in a lot more detail, so that because there are minimal processes which will achieve this that make the wrong kind of trust assumptions for our situation, right? Because what we're assuming is that the square root processes, we're in our chain and in blockchain in general, we're assuming that the square root processes could be malevolent or fallacious. They don't necessarily tell the truth, and so it's this lack of fidelity that creates all of the extra complications, right? So the next level up, and by the way, you can, if you can do this in the setting where you enrich the COM rule to allow for another level of execution, right? I don't know if you remember the row calculus paper, Kent, but I talk about the annihilation COM rule where since names are processes, to check that instead of having the names be equal, to check that one name is the co-channel of another, you run them together. You run the processes whose quotes give you those names in par, and if all paths from that par eventually get you to 0, that's called annihilation, right? And then but now you've used par to you've used COM to define COM, and so you have to check and see if that grounds out somewhere, and it does, because 0 annihilates 0. And then once you see that 0 annihilates 0, then you can use 0 to build 2 more annihilating processes, which is just the singleton send and the singleton receive, right? So they annihilate each other, and now you're off to the races. You can build all kinds of annihilating processes, and in fact, it's even richer than that. You don't necessarily have to go to 0, but that's a much longer discussion. But anyway, so the idea is now you have this multi-level COM idea, right? So COM, you try to do this COM, but in order to do that COM, you have to then drop down a level and run that COM, and in order to do that one, you have to drop down a level until you get all the way down to 0, and then you slowly unwind your way back up, right? So you can do the same thing with the square root idea. So you can but instead of going to 0, you just insist that the process that you run for the names gets you agreement on all races. But since it's now recursing, you have to take that down the next level until you get down to the simplest form, and then you can slowly build your way back up. So that puts even more equational pressure on the thing. So it's more pinned down. It's not allowed to, it doesn't have many degrees of freedom, which is good, because it means that there's very, very few solutions for this particular characterization of consensus. Anyway, so that's what I've been working on. It's I mean, the thing is that it's nice because it's all just math. There's like there, and it's very simple math, which means that we have a ghost of a chance of putting it into a theorem prover like Koch or Isabel or 12 for any one of those, and getting a proof of correctness, because it's much simpler than the way we've done Casper. Does that make sense?
I guess I'm still confused about how the tangle and the square root of a certain process relate.
So think about, we've got 2 minutes. Let's see if I can do this in 2 minutes. So think about trying to define recursively the notion of a square root. So you're going to do a structural definition, right? So the square root of 0. So you're just going to go over all the different process forms. And so the square root of 0 is just going to be 0. And the interesting case is when you go to do the square root of a par. Now, the square root of p par q, if p and q don't interact, then you don't care. So it's just the square root of p par the square root of q. The place where it's interesting is if p and q interact. At that point, you need to produce two things, right? One of which is going to capture the interaction of p and q, you know, and the other of which is going to capture another copy of that interaction. So that when you put them in parallel, they just give you that whatever that interaction is. And that's where the tangle is. So the tangle is the fact that they interact. Does that make sense?
Almost, I guess.
It'll be a lot clearer once I write the math down.
Yes, I think that will be helpful.
Yeah. So I'll that's what I'm working on right now is writing that all down. So really good Casper today. And I'll see you over in the stand-up.
Sounds good.
All right, ciao.